Gradeup National Scholarship Test for ESE and GATE stand a chance to win for a scholarship pool of 50 lakhs. Register for free today.
Good evening, dear students. Hello, dear students. Prashant, hi Prashant. Am I audible and visible, dear students? Come on, dear students, join the session very fast. Hello, dear students, am I audible and visible? Let me know. Very nice, very nice. Come on, join this session very fast. Come on, join this session very fast. Join this session. Ask your friends to join this session. It's very useful session on the machining or metal cutting. So, dear students, very welcome to the Gradeup, and once again very good evening to all of you. So welcome to the Gradeup, the India's largest e-learning platform. And dear students, this is the crash course. It is running on right now. We have taken the subject production engineering, and I hope till now we have completed the casting technology, welding technology. We have completed 2 sessions on metal forming. Bulk deformation is separate and sheet metal is separate. We have seen that, and in the today's session we will be discussing the questions regarding to the metal cutting. So be there till the end. Prashant, Sri Kumar, Giriraj, be there. So this is about me. I am Onkar, having more than 10 years of experience for teaching GATE and ESE. Till now I have mentored more than 10,000 number of students. My area of expertise are production engineering, industrial engineering, fluid mechanics, the mechatronics and robotics as well. So today's session will be on the cutting operation, metal cutting. See, if you look at the previous year question papers, and you might be knowing that. So this is a very high weightage topic in the metal cutting operation. Straight away you can directly get some sort of numericals, directly numericals for around 4 to 6 marks directly. Right, so it is very important. So for that reason, the today's session we have dedicated for this is the 2 parts we are having. This is the today is the first part that we will be having. Okay, Sri Kumar. Okay, nice. So you are coming with all your equipments, tools. Okay, so all the best. So dear students, and I hope once again I am reminding you that if you are not still registered for this GNST, Gradeup National Scholarship Test, dear students. So please go and register the examination on 19th of December. It is tomorrow. So be there, be a part of this test. This is the scholarship pool of 50 lakhs, right? And yesterday also I shown you this slide. Okay, go through the details here. The Abhishek Chaudhary, very good evening, dear. Come on, dear students, join this session. Be there in the large numbers. Okay, and make this whatever we are planning this successful one. Okay, so please see the syllabus, the question distribution, all the things are given here. Just go and do registration and apply and just write the test. Okay, so shall we start? Shall we begin? All are there, and please, yesterday also I was telling you, be the part of this session, not only just watching it. Take the pen, paper and calculators or whatever your calculation equipments in your hands and start doing that and be there, be active in the chat box, so that we'll have some fun, interest in this session. Definitely. Prasad, very good evening, dear. Abhishek Chaudhary, already I welcome you. Jadhav. So at the moment we will talk about this first. Definitely I will guide for that. So shall we begin? Shall we begin for this? Take the first question. So this is the first question. So the following data from the orthogonal cutting test is available with us, where we have observed that we have measured the rake angle on the tool is 10 degree. Chip thickness ratio, they are saying it is 0.35. The undeformed chip thickness they given with the 0.51 millimeter. Of course it is in millimeter. And width of cut is given as 3 millimeter. 3 millimeter, not minute. It is millimeter. Okay. And here student, the tau shear strength of the material is given as 285. Good evening. So the coefficient of friction at the chip and the tool interface is given as 0.65, right? And they are asking you to calculate or determine the cutting force, feed force, normal force on the tool and the shear force on the tool. So please calculate these, all the four things. This is the first: cutting force, feed force, that is FC, FT, normal force N, and the shear force Fs. Okay, so we are trying to see the examples such that we can try to cover all the things from the syllabus and we can solve it here. So definitely in the gate examination they will hardly ask one or two things, but here we try to get all the things, as much things as possible from our side. So चलो चालू करते हैं भाई इसको सॉल्व करना. So rake angle is how much? Tell me the given things. Rake angle is 10 degree. Chip thickness ratio R is given as 0.35. Uncut chip thickness T1 is given as 0.51 millimeter. Tell me width of cut. It is given as, say, W, which is equal to depth of cut. In case of the orthogonal turning operation, you know that in orthogonal turning this feed is equal to uncut chip thickness and B or W is equal to what? Our depth of cut. That you know when you talk about the orthogonal turning. Okay, so it is how much? 3 mm, isn't it? 3 mm. And shear strength of the material is it 280 megapascal? So it is okay, 280 megapascal. And the coefficient of friction is equal to what? Tan of beta. Tan of beta is how much? 0.65. Okay, dear students, so see here. So for calculation of the phi shear angle, definitely we can use this directly. This R is given uncut chip thickness. Then alpha is with us. I see, once again I am telling you, I am here, the base is that I am supposing that, or it is assumed that you are having a very nice command on the formulas, or you know the formula at least, whichever topic we have taken for the discussion. I hope that you are knowing all the formulas related to that topic, and based on that only I am moving ahead. So this is the crash course, dear students. So the important formulae as well as the formulae, or the based on that formula you will be having the numericals. But here I am assuming that you know all the formulas. So tell me, what is the shear angle tan phi? कैसे calculate करते shear angle? It is equal to tan phi is equal to r cos alpha divided by 1 minus r sin alpha. Yes or no? So ऐसे हम calculate करते हैं shear angle अगर calculate करना है तो, isn't it? So tell me the value. What is tan phi? Tan phi is equal to r is 0.35 into cos of 10, because alpha is 10 degree, isn't it, divided by 1 minus 0.35 sin of 10. So please be there and put the values there. Put the values there. I want the answer from you guys, right? So this is only possible when you will actively participate. You will calculate, you will put the answer, put the values there, then it is very nice for me. So tell me, tan phi is equal to how much? How much phi you are getting? The shear angle, first of all we have to calculate shear angle will be how much? So whether it is 20.15 degree, please check it out. So shear angle you are getting here, shear angle. Then once you get the shear angle, definitely dear students, the shear force, yes, Akhilesh, welcome Akhilesh. So once this you get the shear angle, shear angle phi, definitely 20.15, very nice. So that we can definitely, Santosh Nayak, good evening. So be there, don't go anywhere. Just understand, try to solve this question. I am going to solve here only. Your marks are going to get fixed for the metal cutting. Tomorrow also we are going to discuss the numericals on the metal cutting. Today also we are having session on the same, because it is very important topic. So these are the fixed marks. Okay, 20.15. Now if you know the value of phi, shear angle, okay, and you know the value of shear stress, how much it is? 280 megapascal. Shear stress is how much? 285. Okay, 285 is here, 285 megapascal. Then you know very well, dear students, shear force. How to calculate shear force? That is shear area into shear stress. And you know how to calculate shear area. See, this is the shear area. No, you know very well, this is the shear area, which is given as what? This LS into this, say B is what? The width of the workpiece or width of the chip at the base here. Okay, so which is nothing but, and LS in the form of T1 and phi we can write. So sin phi is equal to T1 divided by LS, or LS is equal to T1 divided by sin phi, isn't it? That is shear area is what? B into T1, LS into T1 into tau s. So LS is what? Sorry, it is area is nothing but B into LS, right? This is shear area. So I will write here nicely. See, that is BT1 divided by sin phi. I will write very nicely. This is the shear area into tau s. So this will be my shear force, isn't it? Neeraj, very welcome, dear. So don't go anywhere. Please stick to the class. So tell me, what is B? So width of cut is nothing but, you can take it as the depth of cut or width of cut is same. So here B, T1 is what? B is how much? It is 3 mm, or W you can write here. 3 mm, width of cut is 3 mm into T1 is what? T1 is what? 0.51 divided by sin phi. Sin of phi is how much? 20.15. Just now you calculated, into shear stress 285. Tell me how much is the shear force? Tell me how much is the shear force you are getting. Yes, Neeraj Kumar, very good. Is it 1.265 kilonewton? Tell me how much it is. So you got here the value of shear stress as sheared area into the shear stress. You get the value of shear force here. Sheared area into shear stress. Tell me, I am getting here 1265.8 Newton. Tell me whether it is right or wrong. Just tell me. 1.265. Very good. That means that the value is correct here. Yes, Akhilesh. 1265.8 Newton. Okay. That is 1.26 kilonewton. So one of the answer we have found out. See here, Fs is calculated. Now dear students, cutting force. Now see, once you get the value of Fs, please remember this. Remember this very important thing I am telling you. See, once you know this value Fs, dear students, you can very nicely calculate the rest of things. How? CRCT means? Okay. How we are going to calculate that? We are going to have one standard formula, that is from the merchant circle only we have got this all the relationship between the forces. So definitely I can, or you know very well. Okay, if this is say Fs, so you know this is say Fsn, say this is Fc, this is Ft, and this is a F along the rake face. This is the F, this is the N, this is the beta, this is what? Phi, this is beta minus alpha, this is alpha. So all the things you know, once you just write the very nicely, and all the forces in terms of this R, that is resultant force R in the merchant circle diagram. Okay, so this is a circle, definitely is going to be there, circle is there. So you will get one interesting fact, that is that simple formula, straight away formula, Fc divided by Fs, which is known as universal machinability index, which is equal to cos of beta minus alpha divided by what? Cos of phi plus beta minus alpha. Okay, and you know here Fs, you know here Fs. Now the thing, you know here phi, you know here alpha. Only the thing is beta is not known. So beta is how much in this question? So in this question we know that, see, tan of angle beta, if I take in the diagram, tan of angle beta is what? Frictional force divided by normal force, isn't it? And the friction, by the friction theorem, you know that F is equal to mu times N. So definitely tan beta is equal to what? You know that this is equal to mu. So definitely this tan of angle beta, if I write, which is nothing but the mu, and you are given with the coefficient of friction, that is 0.65, it is given. So tan of beta is equal to 0.65. Now tell me what is beta? Tan inverse of 0.65 कितना आएगा बताओ? कितना आएगा भाई, जल्दी बताओ. So if I write here tan inverse of 0.65, how much? Is it 33 degree? So beta value how much? 33 degree, 33.024 degree something. Please check it out. You got here value of beta. Yes or no? Now you got here phi. You know phi is how much? 20.15. Beta, you know it is 33.024, all are degree, and alpha, you know it is 10 degree. Yes, Kumar. Now tell me, can I write here Fc is equal, Fc is unknown, they are asking Fc is equal to Fs into cos of beta minus alpha divided by cos of phi plus beta minus alpha. Okay, so very nicely, what is Fs? You have calculated 1265.8 into cos of beta is how much? 33 minus alpha is 10 divided by cos of phi is how much? 20.15 plus beta 33 minus 10. Tell me Fc will be how much? Fc will be how much? Tell me. Come on, do the calculation, participate. Tell me how much is the Fc? That is your cutting force. Okay, and see all the things, these formulas are no need to by heart these formulas, dear students. Once you know this merchant circle, see, once you know this is the rake face, you directly come here, that is friction force. this is your FC, okay, and this is your FT. You directly make the formulas. This is your resultant R, okay, this is your shear force Fs and normal to the shear force Fs. So just know this diagram. This is beta minus alpha, and this is the R. Put all the terms in terms of R, that is say sine beta is equal to F divided by R, cos beta is equal to N divided by R. This is N, no, N divided by R. Then you can write say sine of beta minus alpha in this FC and FT triangle, right angle triangle, it will be FT divided by R. What is cos of beta minus alpha? It will be FC divided by R. What will be sine of phi plus beta minus alpha? FSN triangle में FS and FSN में, so it will be FSN divided by R. All the things, cos of phi plus beta minus alpha is equal to Fs divided by R. So once you get this and you want to write all the formulae in terms of R, I can write it is equal to F divided by sine beta, that is friction force divided by sine beta, which is equal to normal to force divided by cos beta, which is equal to Fc divided by cos of beta minus alpha, which is equal to Ft divided by sine of beta minus alpha, which is equal to Fsn divided by sine of phi plus beta minus alpha is equal to Fs of divided by cos of phi plus beta minus alpha. So from this relationship only I have taken this Fc and this Fs. See, Fc by Fs is equal to cos of beta minus alpha divided by cos of phi plus beta minus alpha. Like that you can use this equation, no need to by heart. Once you know the merchant circle very well, you can have this all the formulas in your hand. Anywhere, anytime you can just put the diagram, put the merchant circle diagram, from that you will get this value. Okay, now tell me कहाँ तक आए थे हम भाई, कितना आया FC, कितना आया कटिंग फोर्स. So I hope 1597, 159, very good, 1.97, excellent dear students, very nice. Sri Kumar, very good Sri Kumar. So this is one more answer. Okay, now they are asking the feed force or thrust force. They are asking what is the thrust force. So see that see. If you know the FC, see here only we are getting the solution. See, if you know the FC, okay, you know the beta and alpha values, and just equate this Ft divided by sine beta minus alpha. Equate this portion only. Equate this portion, you will get the value of Ft. Tell me. So if I equate this, see, that is Fc into sine of beta minus alpha divided by cos of beta minus alpha, which is equal to Ft. That is Ft in short way you can write Ft is equal to Fc tan of beta minus alpha. Fc is how much? So Ft is equal to Fc is how much? 1597.42 into tan of what is beta? 33 minus alpha is how much? 10. Tell me how much कितना आया भाई? Ft, tell me the answer. So 1597.42 into tan of 23. Is it 678? 678 Newton. Ft कितना आया भाई? 678 Newton. So this is one more answer. Right? Very nice, Akhilesh, Sri Kumar. Anyone is there who is calculating? Who is there actually? Who is participating? Not just only seeing this, dear. Please join the session. Do something. Do something. This will be very beneficial to you, dear. Next thing what they are asking to see cutting force calculate कर लिया, shear force calculate कर लिया, thrust force calculate कर लिया. Now time to calculate the normal force. See here once again, see. Now nothing to worry about it, just see here, just see. Now we know the relationship. See, that is normal force. This N they are asking, that is this we can equate this fc divided by cos beta minus alpha, or you have the ft value also. So you just equate these three things, or you can equate with this also because you know all these things. Okay, now just n divided by cos beta I can write. देखो यहाँ पे कैसे लिख सकता हूँ मैं, I can write here n divided by cos of beta is equal to fc divided by cos of beta minus alpha, or anything, because you are having now choices. So n is equal to fc कितना था रे, 1597.42 multiply by cos of 33 divided by cos of 33 minus 10. Tell me how much is the normal to the friction. कितना मिला आपको नॉर्मल कंपोनेंट, देखो 1502. लेट मी चेक, 1597.42 into cos of 33 divided by cos of 20. How much it is? 1455. Shri Akhilesh, Shri Kumar, and who is calculating? Anybody is there who is calculating actually here? So n value I am getting 1455. Please check it out. Yes, 1455. That is correct. N is equal to 1455.40 Newton. Akhilesh, let me know whether it is right or wrong. Yes, yes, excellent, excellent, Akhilesh. Right. Very good. See, so all the things we have calculated. We have calculated, see. So we have calculated cutting force number 1, thrust force number 2, normal force just now calculated, and the frictional force or shear force. All the things we have calculated. All the things, 4 things we have calculated. Take the next question. Take this next question. Of course, here we have to use the Merchant's theory. It is written there. Okay, so be there. So see, in an orthogonal turning operation, cutting speed is given. So cutting speed is given 80 meter per minute. Okay, cutting force is given, fc is given 200 Newton. Feed force is given, or thrust force is given 80 Newton. Back rake angle alpha b is given as 15 degree. Okay, chip thickness is given as chip thickness that is T2 is given as how much? 0.4 mm. And very importantly, feed is given, f2 feed is given as how much? 0.2 mm per revolution. 0.2 mm per revolution. Of course, this is the orthogonal turning operation, so no need to worry. It is orthogonal turning operation. Now here, see, for the calculation of, if I say the shear angle they are asking to calculate. So definitely T1 is not given. Okay, so that we can able to calculate the R. Here again the flow velocity, that is chip velocity, is not given. Cutting velocity is given. If you take the ratio of flow velocity of the chip divided by cutting velocity, you definitely get the chip thickness ratio R. Yes or no? But here, by using the Merchant's theory, one thing we can definitely do here. What we can do here, that is, see, tan of angle beta we can definitely calculate. Tan of beta, how? Because by the Merchant's theorem, or by the theory, we can write tan beta is equal to fc tan alpha plus ft divided by fc minus ft tan alpha. This is very famous equation, isn't it? So cutting force कितना दिया हुआ है भाई? 200 tan of alpha is how much? 15 degree plus ft is how much? it is 80 Newton divided by FC is 200 minus FT, that is 80 tan of 15. Okay, by using the Merchant's theorem only. Okay, so tell me what is the beta from this calculation. Tan of beta, tell me tan of beta. So 200 tan of 15, 200 tan of 15 plus 80 divided by 200 minus 80 tan of 15. So it is 0.74. Please check it out. So you are getting this 0.74, which is nothing but the coefficient of friction, and beta you will get from that friction angle. Tan inverse of this answer, it is 36.8 degree. Please check it out. Okay, you are getting this beta friction angle as 36.8 degree. Now you are having beta is equal to 36.8 degree. Yes, Akhilesh. And alpha is equal to 15 degree. Now if you very nicely write the Merchant's equation, that is 2phi plus beta minus alpha is equal to 90 degree. You know this. You can write 2 into phi plus beta, 36.8 minus 15 is equal to 90 degree. So you can nicely write this 2 phi is equal to 105 minus 36.8, 68.2. That will give you the shear angle is equal to divided by 2, 34.1 degree. This is the shear angle. Isn't it? Yes, you will get the shear angle by using the Merchant's theory, Merchant circle. Okay, definitely 2 phi plus beta minus alpha is equal to 90 degree. This is the first solution of the Merchant circle, or this is the first solution by the Merchant, which is actually the very useful only for the synthetic materials, not useful for the ferrous material, that you know, and that is the reason why he derived the second solution, that is 2 phi plus beta minus alpha is equal to Cm. Cm is the machining constant. 2 phi plus beta minus alpha is equal to Cm. So this is the second solution. You know that, you know this very well. So whenever in the examination they say use the Merchant first solution, so this is the Merchant first solution. You know this. Okay, fine. For minimum work done. Okay. Now see, shear angle we have calculated. Now this next it was shear strain. How to calculate shear strain? Very nice. Shear strain कैसे निकालोगे? Shear strain we can, of course, if the time permit, I can definitely show you how to calculate. That is nothing but deformation just before fracture, deformation in the chip just before fracture divided by the minimum distance between the two shear planes. Minimum distance between two shear planes. We can very nicely draw the diagrams and all, and we will get the relation cot phi plus tan of phi minus alpha. That is the shear strain gamma, isn't it? So what is cot of phi? Cot of phi is how much? 34.1 plus tan of 34.1 minus this 15 degree, which is alpha. Tell me how much shear strain is induced here. Sorry, not the rate, only shear strain. Tell me how much is the shear strain induced. कितना shear strain induce हो रहा है इसमें भाई? Please let me know. That is simply for this I will write 1 upon tan of 34.1 plus tan of 34.1 minus 15. It is 19.1. So tan of answer it is 0.34 plus this is tan of 34.1, 1 upon answer it is 1.47. So you will get gamma is equal to 1.47 plus 0.34. It is 1.81. Abhi Krishnan, please tell me. It is 1.8167, 1.8169. That is 1.82. I will write. So I will round off. Gamma is equal to 1.8. Very nice. This is the shear strain. Very good. Okay, so see, I am calculating here. So take it in your hands and do the calculation, or whichever the virtual calculators you are using. So I am not going to write the examination, so this is allowed for me, but you people's virtual calculators. Okay, yes, Vikrant, very nice, very good dear, very good. So next thing क्या पूछिए उन्होंने, work done in shear. Oh, work done in shear, very nice, work done in shear. So see, I have chosen this question such that you can have the hands on each and every area in the metal cutting. Okay, so definitely this much lengthy question will not be there, but some of the part of this question definitely they can ask, right? So this is a practice session, and in that actually we are trying to cover as much area from the metal cutting as we can, right? So you know the work done in cutting, how to calculate work done in cutting, that is FC, cutting force into cutting velocity. Work done in shear definitely we will calculate as the shear force into shear velocity, and work done in friction you definitely write it as frictional force into the flow velocity of chip Vf. Okay, and you also know that the FCVC is equal to what? FSVS plus F into Vf. So the total work done, that is cutting force into the cutting velocity, it is nothing but the summation of work done in friction plus work done in shear. Now very importantly, shear force and shear velocity that you need, isn't it? So can you calculate the shear force? Can you calculate the shear force for a given data? So you know the FC, you know the FT, and you know all the angles. So once again use this ब्रह्मास्त्र. क्या है अपना यहाँ पे, अपना ब्रह्मास्त्र क्या कहता है भाई? So FC divided by FS, मैं उल्टा लिखता हूँ, FS divided by FC is equal to cos of here, yes, phi is there, phi plus beta minus alpha divided by cos of beta minus alpha. So definitely FC is known to you. So Fs is equal to, FC is how much? 200. Very good, 200 into cos of phi is how much? 34.1 plus beta is how much? Please tell me. So beta is how much here? Is it 31? 36.8. 36.8 minus alpha is how much? 15 degree divided by cos of this 36.8 minus 15. Yes, tell me now, tell me Fs, tell me the Fs value. 34.1 plus 36.8 minus 15. So this is cos of answer divided by cos of 36.8 minus 15 into 200. Please check it out. Have you got the Fs is equal to 120.76, or I will write 121 Newton directly, round up to 121. Please check it out. So have you got the Fs value as here 121 Newton? Shear force मिला क्या? Shear force we got it as 121 because हम यहाँ पे shear work done in shear calculate करना चाहते हैं, right? So उसके लिए shear force लगेगा. यहाँ पे कोई shear strength दी नहीं है, but from the force we can calculate that. Very nice. Sri Kumar, very excellent work. Abhishek, Vikrant, tell me the value for Fs. Yes, Now the time is to have the shear velocity. Shear velocity, how much? You know the cutting velocity as 80 meter per minute. So no need to worry, no need to worry. We know very well. There is a velocity triangle, you know very well. This is the shear velocity, making the angle phi here, and this is the flow velocity of the chip which is passing or flowing through the rake face of the tool with this angle. This is the angle of the rake angle alpha, so definitely it will be 90 minus alpha, and this angle will be how much? So 90 minus phi minus alpha, isn't it? So you know very well, by apply the sine rule, you will definitely get the relation between these two velocities because VC is given to you, isn't it? So I can write here by the sine rule, VC divided by sine of 90 minus phi minus alpha, it is cos of phi minus alpha, is equal to Vs divided by opposite angle, that is sine of 90 minus alpha, it is cos alpha. Now very nicely you can calculate the values. Vs is equal to, tell me what I can write, Vc into cos alpha, divided by cos of phi minus alpha. Okay, so we see 80 meter per minute into cos of 15 divided by cos of phi is how much? 34.1 minus 15. So cos of 34.1 minus 15. Okay, 80 divided by answer into cos of 15. So you are getting Vs, shear velocity as 81.77 meter per minute. Okay, 81.7. Very good, Sri Kumar. Very good. Now, if I get the shear velocity, I get the shear force 121 multiplied by the shear velocity 81.77. I will get the work done in shear. So finally, we can calculate work done in shear, which is equal to, yes Vikrant, very good, Fs into Vs. Fs कितना लिया हमने? 121 माना है, इंटू ये आ गई 81.77. ये मीटर पर मिनट में है बेटा, मीटर पर मिनट. हम थोड़ा उसको स्टैंडर्डाइज करते हैं क्योंकि हमको हमारा फोर्स है न्यूटन मीटर. अगर पर सेकेंड में आ जाएगा तो पूरा हम लिख सकते हैं वर्क डन इन वॉट्स और इन जूल्स पर सेकेंड, राइट? So definitely I will write here. Here I have to write this divided by 60 करूंगा तो मीटर पर सेकंड में लिख पाऊंगा. So divided by 60 into 121, 165 watts. Work done. Shear. I hope it is clear. I hope it is clear. भाई आया कि नहीं? ये बढ़िया बात है विक्रांत, वेरी गुड विक्रांत, वेरी गुड. श्री कुमार, वेरी गुड. 165 joule per second or watts. This is the work done or power you have actually spent in the shearing of the material, isn't it? Very nice, very nice. Take the next question. While measuring the steel with the zero rake angle, which of the following expression is correct, where tau s is shear strength of the material and uc is specific cutting power and r is chip thickness or chip reduction coefficient? Okay, actually chip reduction coefficient is T2 by T1. Chip thickness ratio will take, or chip reduction ratio, you can call it as R, which is nothing but uncut chip thickness divided by cut chip thickness, T1 by T2. So what is the answer? Let us solve this question. See, let us solve this question. The question is based on the shear stress and the specific cutting energy UC. So they are asking the ratio of tau s divided by UC. Okay, here it is into R. Okay, so let us solve this. So tau s divided by UC, they are asking. Okay, and they are saying the rake angle is 0. So what we can have here, you know tau s कैसे निकालते? Tau s shear force divided by the shear area, which is equal to what? Fs divided by Bt1 divided by sin phi. You know very well. Okay, so I will write it here. So Fs divided by Bt1 divided by sin phi into UC. कैसे लिखते हैं? Specific cutting energy, you know very well. It is nothing but the work done divided by material removal rate, Fc into Vc divided by Bt1 into Vc. So the Vc cancel out. I will write Fc divided by Bt1. So I will write here UC as Fc divided by Bt1. So Bt1 get cancelled out. I will left with Fs sin phi divided by Fc. Okay, Fs sin phi divided by Fc. And you know very well this ratio, you know very well, Fs divided by Fc, you know very well. What is that? It is nothing but cos of phi plus beta minus alpha into sin phi divided by cos of beta minus alpha. You know this very well because you know Fc divided by Fs, which is the universal machinability index, cos of beta minus alpha divided by cos of phi plus beta minus alpha. You know it very well. I can write now because here what they are saying, alpha is equal to 0 degree. What I can put here? Alpha is 0. So I will get cos of phi plus beta into sin phi. This is the numerator divided by denominator is what? Cos of beta, which is equal to what? This is tau s divided by UC. Isn't it? Now dear, what is cos A minus B? Sorry, it is, yes, cos of A plus B is what? Cos A cos B minus sin A sin B. I will write here cos A cos B minus sin A sin B into sin phi is there divided by cos beta. So if take individual thing and have the division, cos beta get cancelled out. So I will get cos phi into this sin phi minus sin phi it is sin square phi, and sin beta by cos beta it is tan beta. So sin square phi into tan beta. And you know that this tan of friction angle is what? Is nothing but the mu. So I will get it is equal to cos of phi into sin of phi minus this sin square phi into mu. That is the coefficient of friction, which is nothing but tan of angle beta, tan of friction angle. Now dear student, one more thing, that is the turning point here that you should keep it in mind. They are saying alpha is equal to 0. That means what? What is tan phi shear angle? कैसे लिखते हैं हम? Which is r cos alpha divided by 1 minus r sin alpha. If I put alpha 0, so this term is 0, this term is 1. So I will get tan phi is equal to r. That is tan phi, I can write sin phi upon cos phi is equal to r. That will be sin phi is equal to r cos phi. Yes or no? So put this value, Vishnu Arvind, I am good. So see here. So now in this, suppose this is tau s divided by UC. This is the equation that we have got. Say this is equation number A. So if I put the value of this sin phi as a r cos phi in equation number A, say this. So put in A. What you will get? Say tau s divided by UC, tau s divided by UC is equal to cos phi into sin phi is what? R cos phi minus sin square phi. Sin phi is what? R square cos square, because sin is R cos phi into right. So if I take this R cos square phi minus this R square cos square phi into mu, if I take this R cos square phi common, so it will be 1 minus mu R, 1 minus mu R. This is tau s by UC. Okay, so one thing that you definitely get, cos square phi into bracket 1 minus mu R, here multiply by R is there. Now if I want to find out the value of cos square phi, so you know that sin square phi plus cos square phi क्या होता है? It is equal to 1. So that is, and you know that sin phi is what? R cos phi. Ask R cos square, that is R square cos square phi plus cos square phi is equal to 1, isn't it? If I take this cos square phi common, cos square phi into bracket 1 plus R square or R square plus 1 is equal to 1. That is, you will get cos square phi is equal to 1 upon 1 plus R square. Isn't it? Yes or no? So just put this value of cos square phi. Say if I write this equation number 2 or equation number B, so put the value of this cos square phi. What is that? It is 1 upon 1 plus R square. Definitely you will get now this tau s divided by UC is equal to R into bracket 1 minus mu R divided by cos square phi is what? 1 upon 1 plus R square. So tell me what is the answer? What is the answer? So you got here R into bracket 1 minus mu R divided by 1 plus R square. That is the ratio of the shear stress divided by specific cutting energy. When in the machining operation you will be having the rake angle 0. What is the answer now? Tell me the answer. Tell me the answer. क्या आया आंसर भाई? क्या आया आंसर अपना रेशो क्या आया? shear strength or shear strength of the material divided by the specific cutting energy. Yes, so C Calcutta is the correct answer. Okay. Shall I go for the next question? Shall I go for the next? Yes, Achilles, that is excellent. Very good. I hope, please go through it once again for this proof. This is actually the kind of theoretical question you have. But yes, can be asked. Yes, Vikrant, very good, very good, very good. Take this question. Come on, fast. Take this question, solve this. Rake angle given as 10 degree, undeformed chip thickness is given as 0.35 mm. Width of cut B or you can say W or D, orthogonal cutting में width of cut and depth of cut क्या होता है? Same होता है. Okay, which is equal to 4.5 mm. Shear strength of the material 350. Very fast करो भाई, megapascal. Okay. Coefficient of friction 0.6. Estimate the cutting and thrust force. Very fast. Come on. Do it by your own and tell me the answer. I will wait here. Do it by your own and tell me the answer. चलो भाई प्रैक्टिस आप करो, आना चाहिए अब. What they are saying, use the merchant theory for minimum power consumption. Okay, use the merchant theory. So definitely in merchant theory what we are obtaining, tan of beta is equal to mu, which is given here 0.6. you will get here beta is equal to tan inverse of 0.6. so friction angle मिल गया. shift to tan inverse of 0.6, it will be 30.96. I will get 31 degrees, say. Okay, then sine phi is remaining. So rake angle is there, alpha is 10 degree. Chip thickness ratio is not given, or cut chip deformed chip thickness is given, not given, undeformed is given, some data is missing. So definitely from that, by using Merchant's theory only, we can able to calculate this 2 phi plus beta minus alpha is equal to 90 degree. You know this. So 2 phi plus beta 31 minus 10 is equal to 90. So 100 minus 31 divided by 2, it is 34.5. 34.5 degree हमको क्या मिल गया? shear angle मिल गया. Now definitely calculate the, because FC and FT, definitely we have to calculate the shear force. Shear force is no shear area into shear strength is given, that is BT1 divided by sin phi. See, now I am going very fast into tau is because I have solved it very nicely. First question, I hope. So B is how much? 4.5, no? 4.5 into uncut chip thickness, it is 0.35 divided by sine of 34.5 into shear strength 380 or 350. Okay, 350. Calculate. So I am getting here the shear strength as, or shear force as 97. Please check it out. Please check it out. 973. Please tell. Let me know. 973.24. And once you get this, you know that is FC divided by Fs is what? Very easy, cos of beta minus alpha divided by cos of phi plus, very good, beta minus alpha, which will be equal to, you can very nicely calculate FC now, equal to 973.24 into cos of beta, how much kitna tha? 31 minus alpha 10 divided by cos of 34.5 plus 31 minus alpha 10 था. So बताओ FC कितना आया? FC कितना आया? 1604.14 न्यूटन. चेक इट आउट. ये FC एक आपको पूछा था, एंड वैसे जैसे FC आता है तुरंत आपको क्या कि निकालना आता है, FT is equal to what? FC tan of beta minus alpha. I told you already. FC is what? 1604 into tan of beta कितना है? 31 minus 10. So it will be, if you calculate, 615.77. Check it out. Check it out. This is solved by me only. So this is one answer, and this is also the answer. Let me know whether it is done or not. So thrust force पूछा था, that is FT, and cutting force पूछा था, that is FC. So all is done, all is done. 1604, yes, correct. Abhi Krishnan, very nice dear, very nice. और 615, very nice, excellent, excellent. So see, take it as a homework. But here what they are saying, use Lee and Schaeffer theory. Use Lee and Schaeffer theory. What they are saying here, use Lee and Schaeffer theory and solve this question. This is the homework. Tomorrow we will discuss the solution for this. Take it as homework. We will solve. This is also very easy question. If the rake angle is 0, you know that if the rake angle is 0, the coefficient of friction what? Tan beta is equal to what? Fc tan alpha plus Ft divided by Fc minus Ft tan alpha. If rake angle is 0, this term is getting 0. So tan beta is what? Ft divided by Fc. Isn't it? So tan of beta will be nothing but the mu, which is equal to Ft is how much? 500 divided by Fc 1000. So it will be 1 divided by 2. So half. So A is the correct answer. A is the correct answer. Okay, very easy. Next question. Tell me the answer for this. Tell me the answer for this. The two tools P and Q have the tool signature. Both are in ORS. It is given. So what is tool signature in ORS? In ORS, in orthogonal rate system, where the angles are measured with respect to the major cutting edge of the tool, so that the analysis or the research can be the very easy. That is the ORS. So what is the tool signature in ORS? In ORS, the tool signature is like this: the inclination angle, then the effective rake angle. We are having theta S dash, relief angles theta E dash, then C is unchanged, and instead of the side cutting edge, you are having the principal cutting edge angle or approach angle lambda and the nose radius r. Isn't it? So in the question, they have given the ORS tool signature, and they are used to turn the components under the same machining conditions. Okay. And if HP and HQ are the peak to valley distances that you know very well how to calculate, and they are asking what is the ratio. Same ideal and under ideal conditions, unchanged machining conditions, how to calculate. So you know how to get that peak to valley distance. Say from the tool mark, if I able to get some this peak to value distance, this is the H for the tool. So definitely I take into account this major cutting edge angle CS, and this is the minor cutting edge angle CE, and you know the distance between these tips is nothing but the feed given to the tool. Okay, so if I have the triangles like this, this is say C is here, say this is A, this is B. Okay, so this is the CE, here it is CE. If I write here, tan of CS can be equal to, tan CS is what? Opposite side divided by adjacent, that is B divided by H. And if I write cot CE, which is equal to cot CE, this angle, this angle, this angle will be A divided by, again opposite, adjacent divided by opposite, this is H. This is equation number 1 and this is 2. Okay, and if I add this equation 1 and 2, 1 plus equation 2, what I will get? I will get tan CS plus cot CE, tan CS plus cot CE, which is equal to what? B by H plus A by H, A by H, where H is what? My peak to valley distance. So it will be A plus B divided by H plus, but dear, A plus B is what? This is nothing but the feed in mm per revolution. So I will write here it is F divided by H, which is equal to tan CS plus cot C. So definitely I will get the formula. So peak to valley distance H is equal to this feed divided by tan CS plus cot C. So same thing they are asking. Just now tell me what will be the answer. The same condition, the feed will cancel out. So HP divided by HQ will be what? This F divided by tan CS plus cot C for tool P divided by, that is tan CS plus cot C for tool Q divided by F. Isn't it? So F will get cancelled out. Now tell me what is the first thing. So it is not the ASA system. So first of all, it is the ORS system. So From that we have to get, see, lambda in the first tool is given as 65. So definitely CS will be what? 90 minus lambda. So 90 minus 65. How much? It is 35 degree. Yes, 35 degree. And for second tool, lambda is 55. It is 25, no? And here CS will be 35. Yes, tell me what will be the answer now. So for tool 1, that is tool P, it is tan of CS is how much? 25 plus cot of C is 8 degree. Here you can see this is C, which is 8 degree. Okay, and for tool Q, tan of 35 plus cot of 8. So this is the ratio of peak to valley distance from which we can able to have the surface finish. And that is the reason why, dear students, you know that whenever we talk about the effect of the side or a cutting edge angles onto the some parameters, so definitely they are going to affect the produced surface finish, isn't it? Hope it is clear. So tell me what is the correct answer. So yes, B Bombay is the correct answer. B Bombay is the correct answer. Very good, very good. I hope this is useful to you guys. So whatever we have practiced today, I hope it is very, very beneficial to you for your preparations. It is helpful. Let me know. Dear students, do follow me on the Gradeup app. There are also some free series are going on. Take the advantage of that. Be there. Follow me on the Gradeup app. So dear students, once again on Tuesday and Wednesday I will be planning some marathon. Definitely it is for the metal forming and sheet metal working. On that particular topic I will be sending on Tuesday. There will be 2 and a half hour, that is 2.5 hours, and on Wednesday 2.5 hours. Total 5 hours marathon complete metal forming I am going to conduct. So be there, right? Yes, solve this question. A turning tool with the sharp corner and measure cutting edge angle CS is given 60 degree. CE they want to know, and feed is given 0.05 mm per revolution, right? And arithmetic mean surface, that is H is given, H max is given as 3 microns. 3 microns. Once again use the same formula. That is H is equal to F divided by tan CS plus cot C. So H 3 microns, so 3 into 10 to the power minus 3 mm, which is equal to F is 0.05 divided by tan of 60 plus cot unknown C. So tell me the value of C is how much? Please calculate. I hope it is 3.8 something. Yes, tell me the answer. So it is around 3.83 degree. Take it this as homework. Take this as a homework. One theoretical and one numerical question. Very easy. Right? So dear students, this question definitely tomorrow we are going to discuss these questions. So see dear students, these are the courses launched by the Gradeup Super. Very useful courses dear students. Definitely this Vision 2022 is very perfect and nice course for the students who are right now in the second and third year. Very ideal course. You can go through the details. Any queries you can contact on this given number, right? So these are our staff faculties from the Gradeup: Dheeraj sir, Rushi sir, Ankit sir, Chandrasekhar sir, myself is there, Harshit sir, Balaji sir, right? These are our achievers in top 100. This is the subscription pricing. Okay, any query just go and contact on this number. So tomorrow dear student, once again I am going to meet you tomorrow at again 7 p.m. Yes, we'll be discussing this metal cutting part 2. So leftover the topics which are there, based on that we'll see some questions, right? Very nice questions we'll try to get. So thank you for joining the session, and dear students, ask your friends. So wherever you are having your contacts on the social media, also you can share these sessions to your friends and ask them to join the sessions. These are very helpful. Okay, so thank you so much. Once again, tomorrow we are meeting at 7 p.m. Be there, be a part of the session and participate with some energy. Okay, be active there in the chat box. Thank you so much. Take care. Good night. Bye bye.